Today, I will give a really quick company introduction. It's a one-slider, so it won't take long. Then we talk about some of the major industry trends that brought us here today and to develop the HDBaseT graphics card. Then we look at the products in detail and what they're capable of doing, followed by our competitive comparison and essentially why you should care about the graphics card and the receiver at all, followed by our applications and a short video demo. So going about our company, we were founded in April of 2015 by 4 individuals in Taipei, Taiwan. 3 of us are Norwegians and 1 is a Taiwanese. And we are, if you don't know where Taiwan is, it's just on the east coast of mainland China and south of Japan. And we decided to establish ourselves in Taiwan because it's quite difficult to do what we're doing in Norway, simply because a lot of this is moved out. So in Taiwan, we have everything close by. We manufacture and design absolutely everything ourselves. We walked a lot of the trade shows like ISE, Infocom, DSE, and we saw what everyone was doing. There was a lot of the similar items, but with different casing. And we saw that no one was really doing the sources of HDBaseT, and we really want to do something that was a little bit different. We don't want to copy everyone else, and we really want to be disruptive. So this is the core of myself and Klaus as kind of running the company. We want to do something completely different. So disruption is really our motto as individuals and as a company. So just to talk about some of the industry trends that brought us here today. We saw a lot of the display and projector guys were kind of going for resolution, and it's been a continuous kind of battle to go higher and higher and higher. And as you've probably seen online in some marketing materials, you see the resolution versus the viewing distance. And for most application for commercial, where you have, say, a 65-inch display, you're coming towards what we call peak resolution, unless you're doing really massive display walls. So at 8K, you're really nearing the capability of the human eye. And so we kind of saw that projector and display guys were doing resolution, and really caught up in that. And the processor guys, the CPUs, the GPU manufacturers like AMD, NVIDIA, and Intel, they're following Moore's law and they're going exponential, and so they're caught up in processor speeds rather than think about all the other things that a graphics card can do. So it hasn't changed for 20 years. It's still the HDMI display port or one other of these ports that are kind of a limited functionality, one-play feature set. And then we looked at the cable guys, the pipeline guys, and you have the HDMI and display port, and you've probably seen this in marketing material, where we're going more and more capacity for the pipeline, but what you don't see in that marketing material is that the, clicker, there you go, the pipeline's getting shorter and shorter and shorter. So we're going from HDMI 1.4 that could do about 15 to 30 meters, now is down, for the new standards, down to 2 to 3 meters. Doesn't make much sense for us who are doing commercial installations because we need to run distances from the media server to our displays. And then another trend that we saw was the HDBaseT sources. In the Alliance, when we started out, there was only 3 sources. It was a Blu-ray player, it was a camera, and it was an industrial PC. And they had a built-in transmitter inside. So all the system integrators were really forced to use a bunch of dongles, transmitters and receiver dongles, which unnecessarily increases the complexity of your topology and increases the points of failure of your installation. Again, doesn't make much sense because the HDBaseT Alliance want to go purely point-to-point. So we summarized that. We kind of see a peak resolution, and we saw that majority don't really need more pixels because if the viewer is greater than a 3-meter distance, 1080p is usually good enough for a 65-inch display. And this is basic physics. We saw a graphics card doing processor capability, but there's still, we call it dumb graphics card. It has one functionality. And we needed the cables guy going shorter and shorter and shorter, but we need longer distances because we wanted it to be in a climate control air in a safe location. And HDBaseT came on board, and they got the full 5-play feature set, which has a lot of intelligence on the cable and can give us the long distance that we need. And of course, we had very few HDBaseT sources. So all that kind of came together, and we thought, well, what if we rethink what a graphics card is supposed to be? A graphics card is really a transmitter rather than a processing unit. And so it's transmitting one play feature, which is audio and video, over an HDMI DisplayPort cable. So we really wanted to go and take what's already there and increase the functionality of a graphics card. Of course, we realized we can't make a processing unit because that's going to cost a ton of money. NVIDIA CEO Jensen came out recently with their new GPU. He said he spent about $2 billion, 2,000 engineers, and 3 years. 2 guys and a dog can't do that in Taiwan. I'm sorry. But so we can utilize what they have, and we can take HDBaseT and combine it. So let's look at the products. Today we're only presenting our HDBaseT product line because we're part of the wonderful HDBaseT booth, and we're interoperable with all the 200 manufacturers that build HDBaseT products. So 2 days ago, I should say, on Tuesday when we first started up, we launched our product line, a family of HDBaseT graphics card. The TB6 standard is 1080p over 70 meters. The TA6 distance is 1080p over 150 meters. And the TA6 performance is 4K 30 over 100 meters. 6 independent ports, each one capable of delivering that kind of power. And we're showcasing right at the booth. So it's the world's first probably modular graphics card as well, which means that we use MXM modules. So if the processing unit of your graphics card isn't good enough and a new one comes out in the future, we can place that in and we can upgrade the actual functionality of the graphics card. It's full 6 independent channels, so each one can deliver its own content, or we can clone the content over the other six ports. Or we can make a mega stretch desktop up to 12K by 4K resolution. Of course, we deliver audio as well as 3D sync. We have emulated controls. I'll talk about that in a few seconds, which is IR, RS-232, and CEC. And we also have pass-through control if you want to use an IR remote control from our graphics card. And it's half length, which means you can use ITX form factor or mini ITX form factor all the way up to server size. Very high flexibility based upon the compact nature of your installation. We've also built into our graphics cards, probably the only graphics card in the whole world that does this, but we've supercharged it with our own firmware. So everything that we have as far as control is accessible through the serial console, and that can be accessed through your terminal, browser, JavaScript, or ActiveX. We allow then complete access all the way down to your display and your projector. So you can now have a full remote kind of upgrading of your system as well as build it into a cloud-based system. So now you can get remote notifications for all of these features. We have EDID emulation, which means that we do it in firmware. Everyone else does it in software. So if you upgrade your operating system or a new driver comes along, your EDID, because we do it in firmware, is going to preserve your screen orders. We have IR, pass-through, as I mentioned, but we also have emulated IR, which means that we have a universal remote control built into a graphics card. We can do any Samsung, LG, whatever proprietary IR signal that's being sent, we built it into a graphics card. We have full HDBaseT diagnostics built into our graphics card as well, which means that you can essentially certify, verify, and monitor and receive notifications from the installation about the signal integrity of each differential pair on your CAT cable. So if anyone's tampering with your cable, if there's a lot of EMI noise, we get notifications in our serial console so that you can now put that into a cloud-based system and get remote notification on your cell phone. So you can become a proactive system integrator. And we have also universal CEC encoding and decoding of CEC command, which means we can do any proprietary signal. Most installers or companies here are using their own proprietary signals, and we can do any of those. With this, we're also launching the world's smallest receiver. Two of them, I should say. One is the RB1 standard, which gives you the 70 meters. It is coupled with our RB1 standard graphics card. And then we have the RA1 performance, which couples up with our 2 TA6 distance as well as performance graphics cards to give it the full feature set. It's only, this small. So it's 4 centimeter by 4 centimeter by 2.7 centimeters. It's the world's smallest. It's also the most coolest in terms of temperature. It's also pretty cool. A receiver. On that receiver, we pass through all the control signals, the RS-232, CEC, and IR, through a simple port, and that allows you then to do remote firmware upgrades. And it also comes with our proprietary SIR port, which stands for Serial IR, and it has a quad functionality. So through an audio jack 3-pin connector, we have IR receiver, IR transmitter, IR in-out as well as RS-232. So you can, if your display or projector doesn't have HDBaseT built in, we can be compatible with them as well. So let's talk a little bit about why you should even care about these products in terms of value to you. So most HDBaseT installations or AV over IP has a media server, HDMI cable to an HDBaseT transmitter with a power adapter. It could be either 1 or 2 cables over a CAT cable with an HDBaseT receiver on 1 or 2 power adapter cables and HDMI into your display. That means for a simple one-to-one connection, you now have 7 to 9 physical points of failure. So that's okay, say, for a single connection, but let's scale that up to, say, a display wall where you got 6 displays. So now you're up to 42 to 54 physical points of failure. In addition, you got 18 power adapters that need to have power sockets. So now you got to send an electrical engineer down to your installation. That's going to cost you $50, $60 an hour. And you have power installation issues. And you could say, okay, hold on, I'm not going to use transmitters and receiver dongles. I'm going to use a matrix switch, and that's fair. You've reduced your physical points of failure in that installation to 32 to 38 physical points. You still got power installation issues on your receiver side because you got 12 power adapters. Doesn't make much sense. Plus your HDBaseT switch is 6 HDMI in and 6 HDBaseT out. It's going to probably mid-range about $3,000, $4,000. Plus you're not going to find a graphics card that got 6 HDMI ports out. So you got to now transfer the mini DP connector over to HDMI, so you increase even more points of failure here. And it's fair enough. I'm going to use now HDBaseT displays, and or projectors. You reduce the physical points of failure to 14 to 15, which is pretty good. We still got severe cost here and some problem here. So what we want to do with a graphics card is to reduce it from a high of 54 physical points of failure to 6. 6 CAT cables. That's all you got to worry about. And we built in diagnostics in here with HDBaseT. So after the installation, you can really monitor and control that HDBaseT installation. So that's what we're looking. We're reducing your cost, complexity, and points of failure. This is what the worst case scenario of our competitor looks like. A graphics card, 12 power adapters, 12 transmitter receivers, 12 power cables, HDMI cables, and CAT cables. We replaced that with 1 graphics card and 6 CAT cables. Pretty simple. So disruptive, lowers cost, easier installation. So one thing is claiming to be disruptive, another is to show it. And so let me just kind of summarize how we're disruptive. One, we're modular. It means that if you need a new GPU in the future, we can change it out. You don't have to come to us and buy a whole new graphics card. We have full emulated controls. It's the first graphics card in the world that has full emulated controls that gives you now a full IoT solution from a graphics card rather than having to have additional RS-232 or USB cables. It's a mess. So with emulated controls, you don't have to do that anymore. We built in full HDBaseT diagnostics as well as environmental diagnostics. So we monitor the temperature sensors, the voltages, the currents, the signal integrity on each differential pair. And we also built in pass-through IR. If you really have to use a remote control, you can do that. And we're half length, all the way from mini ITX motherboard all the way up to server size. And we're HDBaseT, which means that all the 200 manufacturers that are part of the HDBaseT Alliance, we're interruptible with all of them. And that's part of the certification standards. When we go to HDBaseT and give them our product to test it, it all works together. And it comes, as I mentioned, with the world's smallest HDBaseT receiver. So how do we lower your cost other than being disruptive? As I mentioned, no more power adapters. You don't need an electrician for your installations. We reduce the devices from 54 to a low of 6. So it's a 90% approximately reduction in your system installation for 6 displays. Because of the number of devices, we reduce the points of failure, but also because we have the diagnostics. You can do now remote diagnostics into your server, so you don't have when a end customer is calling you up and saying, hey, your display, what's going on? My display isn't working. You can now remotely go into the server and you can see whether the cable's unplugged or the display is burnt out. We got all of that And you now got remote diagnostic and only have to send down an engineer if you really have to. We got the benefits of CAT cable, which means long distance, is lightweight, it's much cheaper than HDMI and DisplayPort. We got dual fan for redundancy, just both on the graphics card as well on the receiver side with the temperature sensor. So we make sure that it has an extra long lifespan. And as far as easier installation, a lot of this comes from the benefit of a CAT cable. CAT cable is much more flexible and lightweight than an HDMI and DisplayPort cable. And so if you're doing false ceilings, it's much easier to route that cable up there. We can do long distances. As I mentioned earlier, the pipeline's just getting shorter and shorter, even though the capacity is getting bigger. But we can do long distances at 4K. CAT cables are much easier and cheaper to get fireproof and shielded. We're plug and play. We don't have any additional software in our graphics card. The only thing you need to download is a custom driver. No custom driver. AMD driver, straight off from AMD. Works fine. It will come up with all the beautiful Eyefinity and Catalyst control center. So nothing scary. We do everything in firmware. We got screen order preservation with full EDID management and EDID emulation. You could do enormous resolutions by taking all the channels and doing a stretched Eyefinity desktop. We're running in our office in Taipei. You've come and visit us. You're more than welcome to. You come out the elevator, you'll see 6 4K displays doing a 12K by 4K resolution display wall. Or you could choose to run each channel with its own 4K content running 6 4K display walls if you're using daisy chain technology from, say, LG, Samsung, Sony, yeah, any one of them. So disruptive, lowers cost, and easier installation. So what's the applications? We get that question a lot when people come to the booth. To make it very simple, because all of these apply, and we have 3 different types of graphics cards, so each one is applicable for each one. But in essence, any digital signage installation or control room where you have a graphics card and you need to run long distance rather than the 2 to 3 meters that HDMI or DisplayPort is going to give you, our graphics card is applicable. Whether it's a McDonald's installation, digital signage in a shopping mall, for the high-end medical or military, we can do that as well. So short demo, I'm going to show a couple of pictures and then a video. So these are 6 4K videos. My suggestion is, it's terrible image here, but go over to our booth and you can see it in live action. We combined it, as I say, to try to play a game at 12K by 4K resolution. Unfortunately, the gaming engine couldn't handle that kind of resolution, but we show in 12K by 4K. That's the only point. And we put 3 graphics cards in one system and a server-sized motherboard running 18 full HD displays. This is our mid-range product. This was at Samsung showroom in Taipei. So we're blasting out 18 full HD videos, not a problem. And I'm going to show you the video here. We're setting up, pulling the CAT cables, 18 of them, point to point, getting the full resolution. So it ended up being a 12K by 3K control kind of setup. We're booting now Windows, 2 Xeon processors, 3 of our distance graphics cards. And I'm sitting up here now, opening up VLC videos, 1080p, and throwing up each one of them. They're all different to show that we could really do 18 full HD videos with 3 graphics cards. And so I'm zooming in to just kind of show it's a full HD resolution. Of course, there's a lot of compression here because I'm camera filming a video. And zooming out to really show that we're running 18 full HD videos from 3 graphics cards, point to point. Everyone else do kind of display walls. They're taking a 4K video and they're stretching it across the displays. We're really doing point to point, so you're getting the full resolution of each display. In a second, after the little panning to show this and one more angle, I'll show you the CPU utilization of the 2 Xeon processors. We'll get there. Drum roll. So we're going to zoom in here. I don't know if you can see it from here, but the CPU utilization at the moment is going up and down between 17 and 18%. So these 2 Xeon processors are way overkill, so you can lower this down. The alternative to doing this is having 3 AMD graphics cards with mini DisplayPort to HDMI cable adapter going into matrix switch, 18 by 18. That's going to cost you $25,000. we do this with 3 graphics cards, it's going to be over over, I'd say about 80% or less the cost. So here we're following the 20-meter cable. We didn't want to do 100 meters because that was 1.8 kilometers of cable, and 2 guys is a little bit too much. And this is an early prototype of the receiver. You can see the final version over here, getting power over the Ethernet cable. And that's the 18 displays running on 3 graphics cards. And this could do it over 150 meters. So you could put that server room really, really, really far away. One last thing, and that is the team that founded it. We have Geir on the left, one of our investors. We have Klaus, who's over there, and myself, Paul, and Charles. And that's the team, the core team in Taiwan. Of course, we have more people helping us out, but we're the one that founded it. Hi, you're here with advoli at the HDBaseT Alliance booth at ISE Europe. We're showcasing the world's smallest HDBaseT receiver, and we're also showcasing the world's first HDBaseT graphics card. It has 6 ports. Each port can do 4K resolution over 100 meters. And if you want to know more about these 2 products, please come visit our website, www.advoli.com. That's advoli.com. Thanks so much.